everyone. Welcome back to SAT Math Question of the Day. This comes from the educator side of the SAT, from the SAT people, and this may include questions from Blue Book. So that is a shout out. That is a buyer beware. Okay, in the XY plane, line K intersects the y-axis at the point 0, -6 and passes through the point 2, 2. If the point 20, W lies on line K, what is the value of W? Okay, Seth, why don't you go ahead and give it a shot while I open up my...
Okay. So this problem, is about a line in the XY plane, and such a line has an equation that looks a familiar equation. Here is a familiar equation for a line in the XY plane. So let's examine what's going on. When X, so I'm going to go X, I'm going to make a table. There's X and Y, which is the MX plus B, and make a bit of a table, right? So they tell you when X is 0, Y is -6. And when X is 2, Y is 2. Okay. And the question is, when X is 20, how much is Y? So here we go. So the idea is when you move up when you start at 0, the start at 0 at X equals 0, the point on the line over the 0 is at Y coordinate -6. You go up by 2, and you go and then in the Y direction you go up by 8.
Yeah.
Right? Now, for the third line of the table, you go up by 20.
Right.
Which is 10 times how much you go up by 2.
There's a pattern there.
And so when you go up, so here you go up by 8, by 10 times 8. Okay? So then you have to figure out, if you start at -6 and go up by 8, go up by 80, what do you get? Well, it's -6 plus 80, which is 74. So W equals 7.
That is a really, really, really great way to do it. I guess it works out amazing that there's a pattern here. That 20 is exactly 10 times 2. If it was 2 and 17, then it would be the same concept, but a little more computationally more difficult. Yeah, that's a great way of doing it. Yeah. I mean, this is basically a line. They define a line. 2 points make a line. If you have 2 points, you can write the equation of the line. And once you write the equation of the line in the form y is mx plus b, or any form you want, then you would throw 20 into x and solve for y.
Well, what a line means is expressed by the equation, and what the expression, what this form of equation expresses is that when X goes up by something, and it's also called delta.
Yeah.
When X goes up by delta, then the slope means that if you go to the right, the X goes up by delta, Y goes up by M times delta. So what a straight line means is that how much you go up is the same constant multiple of how much you went to the right.
Yeah.
In other words, that constant is the slope.
Right.
So
right.
straight line, the meaning of being straight is that the slope is the same everywhere.
Yeah. So this is So this really gets down to the heart of linear equations. Seth, you really use the big idea of what a linear equation really, really, really means, and that's right. So you're able to get it done without having to do the brutal calculations of calculating the slope, calculating the equation, doing the and then substituting 20 in for x. Yeah,
Yeah.
yeah, yeah. So I could do it the other way, and then we'll also show how to do it on Desmos, which I think will be very useful for people who haven't watched Desmos videos.
Mm-hmm.
So if you want it, you would realize, oh, I need the equation of the line. So you have to write the equation of the line. So you first have to get the slope. And the slope is y2 minus y1 over x2 minus x1. Now, one shortcut you could use with understanding slope is the difference in the x's divided by the difference in the y's. So negative 6 and 2, when you go from negative 6 to 2, you are going up by 8. You are going up by 8. And when you're going from 0 to 2, then you are going up by 2. So it looks like the slope is 4. I'm a little scared because it could be negative 4, but I think it's 4.
No, don't be scared.
Okay. So, yeah, I think
A positive slope means that when you go up go up in the x direction, you go up in the y direction.
right. So
That's
what I would also
positive.
do, just for double checking, is I would make a little graph. 0, negative 6, 2, 2. Yeah, okay, so it's a positive slope. See, it's a positive slope. I always double check myself. Now, in this case, who wants to calculate b? Let's use the form y minus... Oh, no.
Wow. Well, however, so you calculated the slope. Very good. Like you're figuring out how much y went up when x went up by 2, and you got 8. Divide by 2 and get 4.
Right.
Now,
so
what about the y-intercept? They tell you right up front that the y-intercept
Oh, that's true.
is minus 6.
Oh, you're right. There's another pattern in there. You're right. They tell you.
They told you. They told you. And black, they say it intersects the y-axis.
Yeah, you're right.
And they don't just tell you the y-coordinate or where it intersects the y-axis. They give both coordinates to remind you that the y-axis is the points where y equals 0.
No, wait, x is 0.
No, sorry. The y-axis is the points where x equals 0. In other words, the first coordinate equals 0.
Right, so that means the equation where we can write f of x equals y is 4x minus 6.
Yeah.
And we want f of 20.
Then you plug in x equals 20 and you get the answer.
And you get, actually, it's the same idea. Look, the mathematics shows the same thing. Yeah.
Yeah. It's same. Yeah.
Now, without asking whether a calculator can be helpful, you're not going to like this, but you can actually do this using Desmos. And we really have to show everyone how to do it because you should know, if you're going into this thing, you should know how to do this using Desmos. So I need to write down the points. So the points are 0, negative 6, and 2, 2. Seth, you've probably never seen this before. For some reason I can't. Where's my annotation? Oh, here it is. Annotation. We have to clear the annotation. Okay. Watch this. We go to Desmos. Okay, Desmos. Wait, Desmos. Okay, so we make ourselves smaller. Watch this. You write, either you go there and you write the word table, or you just type the word table. And you put in the points. 0, negative 6, 2, 2. First of all, it plots the points. See, there are green dots. Then
Yeah.
you go like this. Y1 is equal to mx1 plus b. Oops, you don't do an equal sign, you do a squiggly sign, the sigma sign. If you
Okay.
type the sigma sign, it essentially says, "Do please, calculator, fit me a curve that goes through these 2 points,"
Oh.
and it's linear. It immediately tells you m is 4, b is -6. So that means you know the equation is y is equal to 4x minus 6. Now, watch this. I think this works. This is actually quite amazing. If you say f of x is 4x minus 6, and you type f of 20, it gets you the answer. Wow, look at that. You could do the whole thing on Desmos if you have
Oh,
the
okay.
Desmos skill.
Yeah.
If you're
Oh.
skilled in Desmos.
Huh.
Wow. Pretty amazing, right? We never saw that. We never had this.
No.
Right? Seth grew up on slide rules, let alone this
Yeah.
thing.
Yeah.
So practice this, please. If you're interested in solving problems like this on Desmos, which you really should know how to do without Desmos, actually sit there and play with this stuff. Okay, but you can
Yeah,
use Desmos.
I grew up on long division on paper and subsequently logarithm tables
Yeah,
and then
Yeah.
slide rules.
right. Where is our?
But by the time I got to college, there was like, oh, how many? I think 4 calculator desks in the whole college.
Yeah.
It was a computer room, and essentially in one table there were 4 calculators, so 4 people could use the calculator at once.
Yeah.
And all these calculators were driven from one electronics box that was the size of a huge suitcase.
Yeah. I missed slide rules by that much. I never actually had to use a slide rule in school. Okay, so let us see how they do it. We gave different methods. Seth, your way is by far the coolest because it requires diffuse calculations, and if you really understand what a linear equation is, you really understand the concepts, you can get to the answer really quickly. Okay, so let's see how they say, oh wait, no, we have to do the 4 questions. Does the calculator help? Yeah, we showed you if you want to use the Desmos, you could do it that way. Is there a pattern to this question? Absolutely. Yeah, the fact that 20 is 10 times the difference between 0 and 2, obviously that's a pattern that helps you. How's this different from a school test? They don't usually... Convoluted questions like this are not usually on school tests, but they are on this test. And they love questions like this where they have a parameter or a variable that you have to solve for. Starting with a guess doesn't apply because it's free response. And the main idea, wow, there are a lot of main ideas here, but really the big main idea is understanding what a linear equation is and how to deal with it. Either writing the equation given 2 points and solving for a point solving for the output given an input, understanding, by the way Seth did it, that a linear equation means that every time you increase the x by a certain amount, the output increases by the slope times x. So they want to see if you know a lot of stuff, and it's all related to linear equations. So study linear equations. So let's see how they do it. I wonder what they do yesterday. I wonder if they're going to do yesterday. Are they going to give alternate solutions? May not. No alternate solutions. The y-intercept. Oh, by the way, the other pattern is that they gave you the y-intercept directly as one of the points. The y-intercept of a line in the xy plane is the ordered pair of the intersection of the line with the y-axis. Oh, okay.
So they employ the given y coordinate of the y-intercept, and then they fit one of the points to find the slope.
Interesting way of doing it.
Yeah.
Very interesting way of doing it. Yes. In other words, a slope in this case is an unknown. So you solve
Yeah.
the
And
n.
then, of course, you cannot figure out the slope by considering the point where x equals 0.
Right.
Right?
Right.
So
Right.
you,
Right. Right.
so they had to use the other point.
Yeah. Yeah. Yeah.
Since they gave you the data for x equals 0, that gives you immediately the intercept. It
Right.
gives you immediately the intercept, but it doesn't tell you anything about the slope.
Right. The slope's really more important than the intercept in many ways, conceptually. And so, they're both important in an equation. It matters where you start, but it really matters how you go from where you start. Yeah. Okay. And then they solve for yeah. By the way, we didn't mention, I meant to say, but Seth wisely interrupted me, that noted the pattern. But if you didn't notice that was a y-intercept, you could have done y minus 2 is equal to 4, x minus 2, using the y minus y1 is mx minus x1. Way of writing a linear equation. You have this, and then you could have thrown 20 in here and solved for y.
Yeah.
You could have done that if you didn't notice the pattern. Look for patterns. Patterns help you. This question has a lot of patterns going on, and in your test, you will see patterns.
Yeah.
Okay. Great. Okay. So I guess today's Thursday. Whoa, we're actually meeting today on Thursday. So today is Throwback Thursday, where we go back to books that look really ancient. Look at this thing. Very OG. And this is from like 20 years ago. And the questions were a little different back then. They changed the SAT in 2016 to be more like what you learn in school. But guess what? This question predates that. So it's a tough question. It looks intimidating. So we give it to Seth, because Seth has the PhD in math, and I have the PhD in mechanical engineering. So we are going to move this around a little bit. We're going to change things around. All I know is that the area of a triangle is related to it's 1/2 the base times the height. So that I know. And if you want to see whatever, something. But there's going to be a pattern here about different heights and different bases. Notice Seth is actually thinking.
Least area. Oh, wow.
This is not good. This is not good.
Okay.
There you go.
Yeah.
Okay, Seth, go ahead. What do you think?
Oh gosh.
Well, I also know all radii are equal. I can tell you that.
Yeah, this is a little tricky. So first thing I notice is that all of the choices are for triangles whose, for angles whose vertex is the center of the circle.
Good observation.
Yeah. And okay. And they actually made it quite easy.
Ooh, yeah,
because they gave a pattern. Yeah. The pattern is, as I said, all of the vertices of the angles are point O.
Right.
And one of the other points is always X.
Oh, that's
so all of those triangles, one of their sides is X.
Oh, and that's
so since the area is equal to 1/2 the base times the height, you just pick the triangle that's based on OX that has the maximum height.
The least height.
Which is obviously the triangle whose other vertex is C.
No, least height, least area. Not most area, least area.
Oh, ouch. Sorry, Charlie. Oh, well, see, mix up least and most. Least and most. Okay, has the most area. Wrong.
Because, in other words, you're saying these all share the same base.
They all share the same base. So the one with the least area is obviously this one, as a AOX. You see here, the one with the least height. See, these are the heights. These are the heights.
Right.
The one with the least height.
Right. Yes. So you have to assume in this case that this is drawn to scale.
Well, there's no other information they give you.
Right.
Least height gives you least area.
Right. Yeah. So that's the pattern.
And that's because all choices have the common base.
Right.
And it's O X.
Yeah. Yeah. Yeah.
Okay.
Yeah.
So this is a two-part, a combination of two steps. One is recognizing that the area of the different triangles varies according to the height of the vertex lettered A through E.
Mm.
And the second is carefully distinguishing between the concept of least and most.
Yeah. Yeah. Well, so
and they help you. They underlined least.
Right. Yeah. You may have caught that mistake on a review if you had time. But also, this is an obtuse. This AOX is an obtuse triangle, so its height is actually this distance. Don't be scared. In an obtuse triangle, the height of the triangle is outside of the altitude of this, at least this altitude of that triangle is drawn outside the triangle, as opposed to an acute triangle like DODX, where the altitude is inside the triangle for an acute triangle. For an obtuse triangle, AOX, the altitude is drawn outside the triangle. So that's a little weird. Maybe that's why they call it an obtuse triangle. Okay.
Yeah.
Right. So this problem was not as hard as it first seemed, and the operative word was pattern. So on an SAT question, the questions can't they can't really take you that long. And if it's taking you a long time, then stop and look for a pattern, because there probably will be one that will allow you to do it faster.
Yeah.
So, okay, I'm Joel. I have a PhD in mechanical engineering. My brother Seth is a PhD in math. We meet hopefully every weekday, and we go over an SAT question. We try to flesh it out, go over the concepts, go over alternate ways of solving it. Now trying to bring in the Desmos calculator when we can. And we hope to give you basically insights on how to do these things. While we don't know what's going to be on your test, we know these concepts will reoccur on future tests. So the concepts are very important to learn. And then go to Khan Academy. They partner with the SAT people, and you can practice on topics that you're a little weak on, practice on the topics you're strong on as well, so that you could do those faster, so you have time for the few hard problems. In terms of the few hard problems, that's the challenge if your goal is to get in the 700s, because you have to get a few of those super challenging problems right. Unfortunately, I don't think Khan Academy prepares you for those questions. They prepare you for the concepts for those questions, but they don't really give you a sense of what those questions look like. Blue Book 4 and Blue Book 6 are must-takes on the math side, and Blue Book 4 and Blue Book 6 will give you a sense as to what some of those super hard questions will look like. If you want other resources that have these types of questions that are really hard to find, we found one. There's this group in California, Prep Pros. They offer this book, Complete Guide to Digital Math. Some of their questions do seem to model the toughest questions you would see on the ACT. They also offer this advanced digital class. This is pretty good. Go to Desmos, go to YouTube, listen and practice Desmos solutions on this test. And I also found that someone showed me a Princeton Review diagnostic test, for pay. One of the things you have to pay for. And there were some questions on there that also modeled some of the more difficult questions. So that was a good sign. The challenge is to find these types of resources. Okay, we don't get paid by anyone. When we see resources that we think can help you study, particularly on those super hard questions, we will share them for you. We'll share them with you. We don't get any money or anything. We are not advertising them. We're just making suggestions from our experience. So I think that's it. Please dislike our videos. We take all our comments very seriously. We try to respond to each one. And I think that's it for today, right? Seth? Did you fall asleep?
Yeah.
Okay.
Yeah.
Okay. Okay, great. Okay.
I didn't fall asleep. I'm dreaming of something.
Right. Good idea.
Without sleeping.
That's the way you think of things, is by dreaming things. Okay, everyone. Have a great day. Take care.
Okay, bye.